We're going to keep working on absolute value inequalities. Please make sure that you understand how to solve those really, really well before you attempt today's assignment. Not having a good foundation on these is very, probably really gonna hurt you if you're trying to do today's work. So let's go ahead and just remind ourselves how to solve an absolute value inequality. So the first step is get rid of anything outside the absolute value. So looking here, we have a minus 3 is bigger than 4. We don't have anything outside the absolute value, so we have already achieved that step. So from here, we split into two inequalities. A minus 3 is bigger than 4. The other one is going to be a minus 3. We switch the sign, negative 4. We have to switch the direction of the inequality as well. So one positive, one negative, and we flip the sign. Then from here we just solve. We add 3, giving us a is bigger than 7. We add 3. We have a is smaller than negative 1. So if we were to answer this in interval notation, you'll notice that we don't have any overlap here, right? There is no number that is bigger than 7 and smaller than negative 1. So our answer is going to be from negative infinity to negative 1, union 7 to infinity. Let's go ahead and try our next one. The first thing we have to do is get rid of anything outside the absolute value. In this case, we have a 4 dividing the absolute value, so let's multiply by 4 to both sides, giving us b. I'm going to do a different kind of b. Is bigger than or equal to 12. From here, we can split into two equations. B is bigger than or equal to 12, and b is less than or equal to negative 12. There is no number that is somehow both bigger than 12 and smaller than negative 12, so I think we're dealing once again with an OR situation. Negative infinity to negative 12, hard bracket because of the or equal to, union 12 to infinity. So let's go ahead into the actual new information for the day. Absolute value by definition is the distance from 0. Any number, once you take the absolute value of it, it will be bigger than 0. I guess I should add or equal to because technically the absolute value of 0 is 0. But for sure it's going to be positive. So the absolute value of 0 is 0. So anything, once you take the absolute value of it, it's going to be bigger than 0. So this is going to be any real number is going to be bigger than 0 once you take the absolute value. We have a fancy symbol for any real number. It looks like so. Okay. Once you take the absolute value of it, it's going to be bigger than 0 guaranteed. Similarly, the absolute value of x is always going to be bigger than negative 1. So once again, the answer is all real numbers. Whereas, think about the flip side of this. Can you take the absolute value of something and have something smaller than 0 afterwards? You can't. There is no number that once you take the absolute value of it, it ends up negative. So the answer to this one is no solution. There is no number that once you take the absolute value of it, it's going to be smaller than 0. The fancy symbol for that is going to be a circle with a line through it. Using similar logic, we can go ahead and conclude that this one is going to be no solution as well. You cannot take something, absolute value it, make it positive, and then have it be smaller than -1. There is no number for which that is the case. So the answer is, again, no solution. Now here's the thing about this. Students love these answers because there is no work to be done once you've declared it no solution. However, you have to be very, very careful. You cannot conclude anything until everything outside the absolute value is gone. So think about doing this first step that we did here before you can conclude it as all real numbers or no solution. So for example, we have -2, absolute value x is bigger than 8. We have to get rid of the -2 first, giving us the absolute value of x and -4. Now here's the thing, what happens when you divide by negative? Flip the sign around. Now we have the absolute value of x is less than -4. So from here we can conclude no solution. There is no number that once you take the absolute value of it, it would be smaller than -4. Whereas this problem over here, -5x is less than 20, we can't conclude anything about it right away because we have a positive number right here, 20, and everything else is inside the absolute value. Notice the position of the -2 outside the absolute value and the -5 inside the absolute value. So from here, we just have to solve it the way we did yesterday. Split it into our two equations. -5x is less than 20, and -5x is bigger than -20. We solve each of these. That's going to give us x is greater than -4, because we divide by -5. And we have to flip the sign around once we divide by negative, and do the same thing over here. That'll give us x is less than 4. So if you were to write that in interval notation, it would look like so. -4 to 4. Because we're looking for a number bigger than -4 and a number smaller than 4. So let's go ahead and do some practice problems here. Now I see that we have a negative number over here and a less than sign. So my instinct says, ooh, this looks like a no solution one right here at the jump. However, I can't declare that until I get rid of everything outside the absolute value over here. So let's go ahead, divide by 2, and that will give us x minus 5, absolute value, is less than or equal to -10. From here, there's nothing else outside the absolute value, so we can go ahead and declare this no solution because there is no number smaller than -10 once you take the absolute value of it. Let's go ahead and try our next one. We have -3 times x plus 4 is less than 9. From here, we're going to go ahead and divide by -3. That will give us x plus 4. That'll be -3 once we do that. What happens once you divide by negative? You have to flip that sign around. So now we have the absolute value of something is bigger than -3. Everything is bigger than -3 once you take the absolute value of it. So from here, our answer for everything is all real numbers. I'm going to go ahead and write the fancy symbol for it. Let's go ahead and try our next one. We have 7 plus 4x is less than or equal to -13. we got to get rid of the 7 by subtraction before we can declare anything. So now we have 4x is less than or equal to negative 20. Once again, we have something less than a negative, so we can go ahead and declare no solution. Let's go ahead and do our last one. We got to get rid of the minus 9 before we can declare anything, so let's go ahead and add 9. That'll be the absolute value of negative 3x is bigger than or equal to 18. So now we're bigger than a positive, so this is just like what we did yesterday. We can split it into our two equations. Negative 3x is bigger than or equal to 18, and negative 3x is smaller than or equal to negative 18. If you flip the sign here, you have to flip the direction of the inequality. So from here, we divide by negative 3, giving us x is less than or equal to negative 6. And same thing over here, giving us x is bigger than or equal to negative 6. Oops, sorry, I made a mistake. It's not going to be negative 6, it's going to be positive 6. So this is an OR scenario. Negative infinity to negative 6, union 6 to infinity. Once again, I made a mistake. I did the wrong brackets, so let's go ahead and fix those. As always, let me know if you have questions.